Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to solve UPSC problems for the subject control systems. For that, I have taken ESC Prelims, Engineering Services Examination Preliminary 2024 paper. Let me start solving the problem. So this is the problem number 1. I have taken from the 2024 paper, UPSC paper. What are the steady state errors for the inputs of 3u of t, 3t u of t and 3t square u of t respectively to the system shown in figure, where the function u of t is the step input. So here one system is given. The given 3 inputs are given. For that 3 inputs, we need to find the steady state error value. Okay. So let me start solving the problem. So we know the given is G of S. This is G of S. And R of S for 3 inputs. 3 inputs are 3u of t, 3t u of t and 3t square u of t. We need to find the steady state errors for these 3 inputs. So let me write the formulation for steady state error. Steady state error is denoted as ESS. It is nothing but the error at infinite steady state condition. That means limit t tends to infinity E of t. It is nothing but the error value at t tends to infinity. In S domain, we can write this as limit S tends to 0, S into E of S, where this error signal in S domain can be written as limit S tends to 0, S into R of S by 1 plus G of S, H of S. So this is the common formulation to find out the steady state error value. This is the common formulation. For any input, we can use this formulation. Okay. Now, let me take, I am taking first 3u of t. Okay. Let me take Laplace transform of 3u of t is nothing but R of S, which is 3 by S. So I am taking the input as 3 by S and let me find the steady state error value for this input by using this formulation. Okay. So ES is equal to, that means steady state error value equal to S into, instead of R of S, I am substituting 3 by S whole divided by plus G of S. Instead of G of S, I am going to substitute the given value 120 S plus 2 by S plus 3 into S plus 4. Okay. Here in the numerator, S gets cancelled. So then simplifying, it will become, so this is limit S tends to 0. So by simplifying, limit S tends to 0 of, in the numerator, 3 into S plus 3 into S plus 4. And in the denominator, S plus 3, S plus 4 plus 120 S plus 2. Now, by applying the limit S as 0, this will become 3 into 3 into 4 by, in the denominator, 3 into 4, 12, 12 plus 120 into 2, 240 plus 12, 252. So let me cancel the values. 4 by 252, 4 6 are 24, so 63. So 3 by 63, 3 by 21. So again we can cancel. So in between we can check out the options. So in the option we are having 3 by 21. In the option A we are having 3 by 21 value. So let me check out for that. So let me stop with this. 3 by 21 equal to steady state error value for the first input. Okay. For 3u of t input. Okay. And then let me check the other answers also. So this is our second input. 3t u of t is the second input. So if we take the Laplace transform of 3t u of t, it will become 3 by s square. So 3 by s square equal to R of s. So if we substitute R of s as 3 by s square in this same formulation, so s into 3 by s square will come in the numerator. So one s will get cancelled and another s will be remaining at that place. So anything by 0. If we substitute, if we apply the limit in that, if we apply the limit s tends to 0 in that, then anything, any term by 0. It will arise as any term by 0 that will be definitely equal to infinity. So for the third input also the same. So it will be 3 by s square, so that it will be also infinity. Okay. So for the second input, infinity, and for third input also infinity only. Third input also ESS equal to infinity. For second input, ESS equal to infinity. Okay. So answer for the first input, this is for the first one, and this is for the second one, and this is for the third one. First, second, third. 3 by 21, comma, infinity, comma, infinity. So let me check out the options. So in option A, we are having the values. 3 by 21 is the steady state error value for 3u of t, and infinity for 3t u of t, and again infinity for 3t square u of t. So this is the formulation to find out the steady state error value for all type of inputs. For any type of inputs, we can use this formulation and we can find out the steady state error value. Okay. So let me take out the answer. Option A. Option A is the correct one for the given problem. So let me move to the next problem. So this is the problem to find out the transfer function of the given circuit. To find out the transfer function for the given circuit. So for the given RLC circuit, we need to find the transfer function. So first, what do you mean by transfer function? Transfer function of any system is equal to Laplace transform of output to the Laplace transform of input. It is the ratio of Laplace transform of output to the Laplace transform of input with 0 initial conditions. So this is the definition for transfer function. Okay. So Laplace transform means in S domain. We need to find the transfer function in S domain. So for that, I am going to convert this circuit in S domain first. Okay. So let me convert. Okay. Laplace transform of input V of t, we can write that as V of S. And Laplace transform of output Vc of t, we can write that as Vc of S. Okay. And then for the impedance values, or it will be constant only. And for the inductance, Ls. And for the capacitance, we can write that impedance as 1 by Cs. Okay. So the current value is I of S. So we need to find the transfer function. So what is the transfer function for the given circuit? Laplace transform of output to the ratio of Laplace transform of output to the Laplace transform of input. So we need to find the ratio Vc of S by V of S. So this is the equation. Okay. So for that, we can find the Vc of S value. So now I am going to apply voltage division rule. By applying voltage division rule, we can find the voltage across capacitance. Okay. So voltage across capacitance can be taken as Vc of S. So now Vc of S equal to, by applying the voltage division rule, Vc of S equal to total voltage is V of S into that respective resistance, that means respective impedance is 1 by Cs, by the total impedance is R plus Ls plus 1 by Cs. So we need to find the ratio of output, Laplace transform of output to the Laplace transform of input. So here from this we can rearrange Vc of S by V of S equal to, by simplifying, 1 by Cs in the numerator, and here RCS plus LCS square plus 1, the whole divided by Cs. So again, CS get cancelled, and by taking LC outside in the numerator, in the denominator, so it will become 1 by LC in the numerator, and in the denominator S square plus RC by LC, C will get cancelled. So R by LS plus 1 by LC. Okay. So let me check out the answer in the options. So in all the option, numerator, in the numerator we are having 1 by LC. So we will check out the denominator. Denominator is S square plus R by LS plus 1 by LC. So here in the option A, S square plus R by LS plus 1 by LC. So in the option A itself, we got the answer. So we can tick out the answer, tick out the option A. Option A is the correct one for the given problem. So like that, we can find out the transfer function for any circuit. So let me move to the next problem. So this is also to find the response. The open loop transfer function of a unity feedback system is given. What is the time response subjected to a unit step input x of s equal to 0.8 by s? So here g of s is given, x of s is given. We need to find the time response. We need to find the time response. Time response. That means response in time domain. Okay. So normally the closed loop system is will be like this. Here x of s is given as input. G of s is the open loop transfer function that we know. So since this is a unity feedback system, there is no feedback element connected here. This is the unity feedback system. And output we can take it as y of s. So we need to find the time response. Response in time domain. That means we need to find y of t. So first we will find out y of s. Then we can find out y of t by taking the inverse Laplace transform. So here g of s is given as 20 by 0.21 s plus 1 and x of s is given as 0.8 by s. So from this we can find out the transfer function. So y of s by x of s equal to, for the unity feedback system, we can write this as g of s by 1 plus g of s h of s. So here h of s equal to 1. So no need to write that. So 1 plus g of s only. So let me substitute the value of g of s. 20 by 0.21 s plus 1 by 1 plus 20 by 0.21 s plus 1. By rearranging 20 by 0.21 s plus 1 by whole divided by 0.21 s plus 1 plus 20 by 0.21 plus s plus 1. So in the numerator and denominator, this whole term will get cancelled, and again it can be simplified as 20 by 0.21 s plus 21. And by taking 0.21 outside, 20 by 0.21 by s plus 21 by 0.21, which is equal to 20 by 0.21 s plus 100. Okay. So let me find y of s from this by substituting x of s. So y of s equal to x of s into 20 by 0.21 by s plus 100. That is, by substituting x of s as 0.8 by s into 20 by 0.21, the whole divided by s plus 100. So which is equal to 0.8 into 20, 16. So 16 by 0.21 is the constant value by s into s plus 100. Okay, this is the response in s domain. We need to find y of t value. That is a response in time domain. For that, we have to take the inverse Laplace transform. So before that, we need to use the partial fraction expansion, and then we have to take the inverse Laplace transform. So let me start solving that. So here we found out y of s as 16 by 0.21 by s into s plus 100. So by partial expansion method, a by s plus b by s plus 100. So by simplifying, 16 by 0.21 equal to a into s plus 100 plus b into s. So for finding out the partial coefficients, we can put s equal to minus 100. So if you put s equal to minus 100, this will become minus 100b equal to 16 by 0.21 is nothing but 1600 by 21. So here 100 will get cancelled. So b equal to minus 16 by 21. So approximately 16 by 21 is 0.76. Approximately we can take this as 0.76. So minus 0.76. So like that, if we put s equal to 0, then 100a equal to 1600 by 21. Here also it will get cancelled. So a equal to 0.76. So by substituting in y of s, 0.76 by s minus 0.76 by s plus 100. So y of t is inverse Laplace transform of 0.76 by s minus inverse Laplace transform of 0.76 by s plus 100. So same constant, so we can take it outside 0.76. 1 by s, inverse Laplace transform of 1 by s is nothing but 1 minus 1 by s plus 100. Inverse Laplace transform of 1 by s plus 100 is e power minus 100t. So let me check out the answer. This is the time response. Time response subjected to the input x of s. Okay. So 0.761 minus e power minus 100. Let me check in the options. In option A, we are having 0.761 minus e power minus t by 100. So here we are having minus 100 into t. So it is different. There is so option A is wrong only. Let me check out for the option B. 0.76 into 1 minus e power minus t by 0.01. So it is nothing but 1 by 0.01 is nothing but 100. So 1 by 0.01, 1 by 0.01 is nothing but it is 100. So we can take it as this is equivalent to 0.76 e power 1 minus e power minus 100t. Okay. So option B is the correct one for the given problem. This is the time response. So let me start solving the last problem. What is the status of the closed loop transfer function T of S? So one transfer function is given using Ruth Hurwitz criterion. So using RH criterion, we need to find whether the system is stable or not. The given options are unstable, marginally stable, stable, neither stable nor stable. Okay. So we need to find the Ruth array. We need to form the Ruth array, and by that we can find out whether the system is stable or not. So from the given transfer function, let me write the characteristic equation first. The characteristic equation is given as s power 5 plus 2s power 4 plus 4s cube plus 6s square plus 2s plus 5. So I am going to form the Ruth array. So by Ruth array, So let me write the values, write the coefficients first. So we have to form the first two rows by writing the alternate coefficients. So s power 5 row, first coefficient is s power 5 coefficient 1. Then next alternate coefficient is 4. Next alternate coefficient is 2. That is s coefficient 2. And then s power 4 row, s power 4 row coefficient, s power 4 coefficient is 2. Alternate coefficient is 6. Alternate coefficient is 5. So let me form the Ruth array. So for the s cube row, the calculation is 2 into 4, 8. 8 minus 6 by 2. 8 minus 6 by 2. 8 minus 6 is 2. 2 by 2 is 1. And then next for the next element, 2 into 2 minus 5 into 1. So 2 into 2, 4. 4 minus 5 minus 1. Minus 1 by 2, it is minus 1 by 2. And then next row. So by taking the s power 4 row and s cube row. So 1 into 6 minus this one, minus this product by 1. Okay. So 1 into 6, 6. 6 plus 1, 7. 7 by 1. Okay. And then next one, 1 into 5 minus 0 by 1, that is 5 only. And s power 1 row, 7. 7 into minus 1 by 2, minus 7 by 2, minus 5, minus 7 by 2, minus 5 by 7. Okay, 7 minus 10 minus 17 by 2. Okay, minus 17 by 14. And then s power 0, again, simplifying this, 5. Now, let me check out the first column of the root array. First column of the root array. Whether there are sign changes. Whether there are sign changes. First column of the root array is this one. So, we are having 1, 2, 1, again 7, minus 17 by 14, 5. Okay. So, this is positive and this is also positive, positive, same sign. And here also same sign. And here negative sign. Again here positive sign. So, from the s square row, there is one sign change. Again negative to positive. Again second sign change. So, there are two sign changes. Two sign changes in the first column of the root array. That means we can conclude that the number of roots is 5 roots. So, out of 5 roots, there are 2 roots are lying in right half of the S plane. Lying in right half of the S plane. So, we can conclude the system unstable. Unstable system. So, for a stable system, all the roots should lie in the left half of S plane. Left half of S. If even any one root is lying in the right half of S plane, we can conclude that system is unstable system. So here in this given system, there are 2 roots lying in the right half of S plane. So we can conclude the system is unstable. So we can check out the answer. Option A is the correct one. This is the unstable system. So this is Mani's Gate Tech Vision. This is a channel for engineering lectures. You can subscribe to the channel. You can view the lectures freely. This is my mail ID, dmanilecture@gmail.com. If any queries means you can mail to me. Thank you very much for watching the video.